Welcome. I'm your host, Neil Howard, here on Health Professional Radio. In this Health Supplier segment, we're going to have a conversation with Mr. John Davenport, Chief Scientist at Energy Focus. Now, our Health Supplier segments are focusing on people who supply the healthcare industry with technology, ideas, instruction, or something of that nature. And in this segment, we're going to talk about fluorescent lighting and first-generation LED lights and how the flicker effect can affect us and may also interfere with some hospital equipment. Welcome to the program, Mr. John Davenport. How are you?
Hi, fantastic. I'm delighted to be on. Thank you for inviting me.
Now, talking about LED lighting, give us a bit of your background. What is it about lighting? I mean, are you a scientist as far as lighting is concerned? Are you a healthcare professional that transitioned over into manufacturing for some reason? What's a little bit of your background?
Yeah, my background is physics, and in particular the physics of lighting. And I have worked on lighting for a long time. Actually, I have been in lighting for 45 years, 25 years with General Electric Lighting, and I ran R&D for GE Lighting. So I've worked with all of the lighting technologies, and I was involved in the development of LEDs in the very earliest stages, coming to Energy Focus around 2000, and working with the U.S. Navy. And it was really there that I got excited about it, because they gave us a clean sheet of paper and said, what are we going to do for the next generation of lighting? And we started off with all sorts of ideas and came to LEDs as the way to go, and learned how sailors, for example, what they need to really be effective on board ships, and worked with researchers in understanding things like circadian lighting, which of course is something that we find all over nowadays. So that's my background.
Is this a fluorescent lighting versus LED lighting? Not all of the lights that we see, office lights are fluorescent lights, right? What is a fluorescent light, and what is an LED?
Okay, terrific. That's a great question. Right now, fluorescent light, and I'm talking about the long tubular lights that are typically in the ceilings, in schools, in offices, and in hospitals, for example, that provide general lighting. They work by means of a mercury discharge. So there's UV produced by the discharge, the mercury inside. It's kind of like bottled lightning, and it radiates to phosphors, which convert the UV to white light, usually 3 in chunks, and that's one of the problems. But it does make white light. It has significant red, blue, and green content, and they combine in your eye to make white light. And so that's the fluorescent technology. And in fact, fluorescent has been the choice original choice in the hospitals, schools, and offices, because it was much more efficient than incandescent, a much more cost-effective choice. However, this white light we talked about has come with a set of trade-offs. The spiky color spectrum that I just talked about is deficient, particularly in red, and it still produces some of that UV gets out of the bulb, and you get some UVA and near UV radiation, which can be a problem. There's also, because it's a discharge, it's almost a vacuum inside this glass tube, and if you drop it, it'll implode, and you'll have glass flying everywhere and mercury. So not really good if you drop one of these things. If you've ever felt uncomfortable under fluorescent light, you are not alone. Almost everyone has at some point. Many experience headaches. Some people are particularly sensitive. Children, for example, especially children who are somewhere on the autistic scale, and individuals with scotopic sensitivity syndrome. There's even evidence that flicker can cause seizures in patients with photosensitive epilepsy, and that high levels of flicker interfere with reading. There's a groundbreaking study that Dr. Arnold Wilkins did from the University of Essex that demonstrated that point. So that's the situation with fluorescent. Great lighting for its time, but LEDs really address all these concerns. And for example, the LED tubes emit light in a continuous, non-spiky spectrum. They're more like the sun, which is really what we should be making indoor lighting like. And all the colors are present in a smooth and continuous way. There's no UV. They don't emit UV. And there, of course, there's no mercury discharge, so there's no mercury to worry about, no vacuum, and no glass breakage. They also offer a full range of colors, from warm white, which is kind of like the sun rising or setting, or cool white like the sun at noon, and everything in between. And so they can provide really nice settings in a hospital. For example, the patient room might be using warm white, which is more appropriate for them, where the nurses and the doctors are working under the higher color temperature light to keep them awake, right? Which is a good thing at night. But the thing you talked about earlier, and I'd like to talk about for a moment, is flicker. And this is where LEDs can be better or worse. So we've been talking about how they can be better, but here you can actually make them worse than fluorescent. You've seen flicker if you've ever seen a fan turning in an auditorium in front of a ceiling light. Okay. The light looks like it's blinking on and off as the fan blade goes by, maybe 10 times a second. Okay, so that's kind of flicker that's very apparent. But electric lights run on AC or alternating current, in which the current goes through zero 120 times a second, which is very fast. But LEDs are very fast. So they will go out completely 120 times a second if the circuit controlling them doesn't keep them lit while the current is zero. While you may not be consciously aware of what's going on, your retina and your mind in an unconscious level certainly is, and you're trying to process this information. It causes problems. You could easily see this, incidentally, if you have a smartphone. You just take a short video of a light in the slow motion mode and play it back. You'll see the blinking, just like the fan blade in front of the bulb in the ceiling in an auditorium. Many first-generation LED lamps go completely out when the power goes out. Almost all have very significant levels of flicker. That is more than 20% change in light output at 120 times a second. A few manufacturers, and of course we're one of them, have completely eliminated flicker as an issue with UL-certified light flicker of less than 1%. In other words, the light output changes basically so low that it's difficult to measure, far less than the 5% low risk or physiological threshold recommended by the IEEE, a number based on consideration of many, many scientific studies. These, of course, are the LEDs I recommend for use in hospitals, schools, really everywhere, right? Why would you introduce flicker?
So these flicker-free LEDs are widely available via your company?
Well, everything that we produce is flicker-free. Under 1% is flicker-free. You just can't measure it. There are other companies that are lower than the 5% threshold, but there are many, many companies who are not, and who really haven't paid very much attention to this. The industry is kind of waking up to flicker and trying to understand what the level should be. We've decided that why wouldn't you eliminate it? It's technically possible. It doesn't cost very much to do it. You have to your bulb has to have a little bit of intelligence in it, so that you monitor the light and make sure that it isn't changing. But so we decided to just do it, and basically because it's the right thing to do. It really is the right thing to do.
You talked about how this some of these lights affect certain people. How can flicker from fluorescent lights or first-generation LED lights affect hospital equipment?
Oh, sure, because flicker changes light level, and we use equipment. We have readers, just like the same things you have in grocery stores to check out counters. Those basically are optical readers. If you have high frequency flicker in the light, you can interfere with that equipment. And in fact, we saw one manufacturer who actually froze up the checkout counters because they couldn't read the prices. So you have to be careful about light output variations. That they can cause problems with equipment. Also, if you have rotating equipment, you can get strobing effects. And of course, in an operating theater, there's rotating equipment. And your hand could be in a place where you don't think the equipment is because you're going through this strobing effect, and you could wind up with an accident. So it could be very dangerous.
Where can we go and get some more information?
Go to our website, www.energyfocus.com, for more information. And there's lots there.
John, thank you so much for joining us here this evening on Health Professional Radio for this Health Suppliers segment.
Great. Thank you.
You've been listening to Health Professional Radio. In this Health Suppliers segment, talking with John Davenport, Chief Scientist at Energy Focus. Audio of this program is available at hpr.fm and healthprofessionalradio.com.au. You can also subscribe to the podcast on iTunes. Listen in, download it, SoundCloud, and be sure and subscribe to our YouTube channel at youtube.com, Health Professional Radio.